Hello everyone. Let us now discuss how can we solve this today's LeetCode POTD problem. Apply operations to maximize score. We are given with nums of n positive integers and an integer k. Initially, you start with the score of 1. You have to maximize your score by applying the following operation at most k times. Now, what is the operation? Now, in one operation, we need to choose non-empty subarray from L to R that you haven't chosen previously. Now, for clarity, let me say that firstly, let us understand the question, read the description whole. Choose an element x of nums L to R with the highest prime score. If multiple such elements exist, choose the one with the smallest index. So they are saying that x, we need to select an element x from L to R, this subarray with highest prime score. Now let us see what is this prime score. And by choosing the element, multiply your score by x. Now let us see what does this prime score mean. Here, nums L to R denotes the number of the subarray of nums starting at index L and ending at index R, both ends being inclusive. That means L and R also taken into consideration. The prime score of an integer x is equal to the number of distinct prime factors of x. For example, the prime score of 300 is 3, since 300 is equal to 2 into 2 into 3 into 5 into 5. So that means the number of distinct prime factors are 2, 3 and 5. That's it. So for 300, the prime score is 3. This is about the prime score. Now, return the maximum possible score after applying at most k operations. Now, when they say at most k operations and they given that L can be from L to R. Now, if I see the constants, k will be less than minimum of n into n plus 1 by 2, comma 10 power 9. That means it would be at least half the size of the array. Now let us see if the size is half, then at least I can take each and every element. So that means I can take all the k values. First observation. This is the first observation. Let me write it. So k is lesser than or equal to half the size. Half the size. Now let me think in such a way that here I am given with an array and the k value is exactly the half, and I am given with some values like 1, 5, 4, 12, 10 and then 6. So this is the size of the array and k is equal to 3. Now can I take all the 3 elements? Absolutely, because if I take something like I am not considering any prime score, so randomly I am selecting the toppest elements 12, 10 and then 6. So my first observation is take all the k operations. So do all the k operations. Now, this is my first observation. Prime factor count. So, 8 is having a prime factor count of 2 and 3 is having 1, 9 is having 2, 3 is having 1, 8 is having 2. So, that means here for 8, wait a second. For 8, I need to write all those prime factors. So, I can represent 8 as 2 into 2 into 2 into 1, but here I am considering 1 as a prime number. Let us see, is 1 a prime number? Yeah, no, 1 is not prime number. So let me decrement every number's prime count by 1. If I do that, right, 1 here, 0 here, 1 here and 0 and then 1. So I am only considering all those prime numbers instead of 1. I am excluding 1. Now let us see what happens. Here prime factor count, I am storing the prime factor count in another array. Now how do I get these subarrays? First thing, what is the subarray? Let us see what is this subarray. Now I can take this subarray. They said, and I am also confused that they took something like a subarray here and another subarray like here, right? But they said again here that choose any non-empty subarray that you haven't chosen previously. That means they are talking about the entire subarray, not the element, not the indices. It's not given that if I take the subarray this and I can take this subarray this and only I am allowed to take another subarray which doesn't include the indices that I took in previous subarray. I can also take the subarray like this. I can also take the subarray like this. I can also take the subarray like this, but not the same subarray. So this is about the subarrays which are given in the question. Now let us do one thing. Let us take this element and let us see what happens if I take a subarray with this. Now I am only considering, let me write it. I am considering all the subarrays with 19 as dominant. I am saying the dominant element. That means 19 should be having the number of prime factor count is 1 and here it is 3. So that means I need the subarray where 19 would be the greatest element. 19 should be the dominant element. There should be no element in the considering subarray which will be having greater than 1 prime factor count. Now let me see, can I get a subarray? There is no element at the left, so I can't get a subarray on the left. So let me go to the right. So if I consider the next element 3, 3 is, I am not talking about the value of the element. I am talking about the prime factor count of that element. So here it is having 3. But if I consider this subarray, then 12 would be the greatest or the dominant element. So that's why this 12 I need not to consider. This subarray I would not consider. I would consider only this subarray. So with index 1, there is only one subarray that I can get. Now let me take this 3 as so next element is 12, but I am considering 3. That means I am talking about all those subarrays where this element would be the greatest element or the dominant element, not according to the value, according to this 3. So let me do one thing. Let me erase this for some time. Don't consider these values for some time. Just consider this subarray, sorry, prime factor count. Now this is one subarray that I can get with dominant element as this index. Now can I consider this? Yes, absolutely. Even then, if I consider this, 3 is the maximum number. This index would be getting the dominant element. Can I consider this subarray? Yes, absolutely. I can consider this. Even I consider that I would get 3 as the dominant element. Now I can also consider this subarray. I can also consider this subarray. This and then this. Sorry. Till here only I can consider. But not till here. But why? If I consider the subarray with having this, then I would be confused whether to take this index and multiply for subarray number of times or take this element. Now, what I mean when I say that counting the number of subarrays, right? So here I am taking this subarray count for something like I need to get the number of subarrays. So here I have 3 as the prime factor count and having 12 as the value. So every subarray that I take, I would multiply it by 12. multiply the score by 12. So if I am taking one subarray, then I need to uh, multiply my score by the dominant element in this subarray. So if I am considering one subarray, then I am multiplying my score by dominant element for one time. If I consider for n times, then let me consider x as the dominant element, then score would be multiplied x for how many times? N times. Instead I would write this like x power n. So if I have n subarrays and the dominant element is x in all those n subarrays, then I need to multiply my score by x power n. So this is how I take the subarrays. But how can I get the number of subarrays? How to get subarrays for every element? How can I get those subarrays? Now let me consider an array which is having, don't ever look at the values. I don't consider these values. I am only bothered about the prime factor count. Now let me start with here 1, and then here 3, and then 2, and 1 again, and then 3. Now, let me tell you how can I get the number of subarrays for every element. So, I would store this in here. In here. Here, I would store the number of subarrays that I get. So, 1 is the only subarray, right? So, if I go to right, here, I don't have, so sorry, here, I don't have any element which is lesser than, which is lesser than 1. Yeah, right, which is lesser than 1. I don't have anything right on it. If consider that here, instead of here, the 3 is something way another time, but even then I cannot consider, right? Because if a number is having 1 as the prime factor count, then even then another is having 1. As I said, if I consider two elements far apart or just adjacent, I would confuse to whether consider this element or this element. So the element at this index or the element at this index. So don't consider the elements with the same factor, prime factor count. Now, let me say here I got 1, so there is no chance, so only one subarray, that is itself. Now I have 3. Now here comes the actual thing. I can take this, I can take this, I can take this, and then also this as a subarray. I can also take this, but I can't take this. So totally the number of subarrays that I can get is here the the next element which I get equal to 3 is at index, let me write those indices, 0, 1, 2, 3, 4 is just 4. So I can take the subarray still here. Now the index where I get the previous greater, here the previous greater should be at least 3 or greater than 3, but I didn't get any 3 before. So for this I would say that I would consider all these things. Now 0, 1, 2, 3, 0, 1, 2, 3. But I would consider these subarrays. The number of subarrays that I can get here are 1, 2, and then 3. Now the number of subarrays that I can get with this is here. Here firstly I got 1, 2, and then 3. Firstly I got 3 from the right, and how many I get from the left? 1 and 2, just 2. Now should I add or should I multiply? Let us see. If I just add it, then I'll get only 5. But here there is another subarray that I can consider, the whole subarray. So I would multiply 3 into 2, then I would get 6 subarrays with including, which includes 1. Now, let us consider this example. How can I get? Here I have given with the elements, and here it is the prime counts for every element. So let us not indulge in these elements, but let me take this example of prime counts. Now, what I do is taking a stack and pushing this index into the stack 0, 1, 2, 3, and 4. And initially, the previous greater, and also next greater, next greater would be initialized to n for every element, and -1 for every element for previous greater, and for next greater it would be n. Now let us see. Let me push this 0 index into the stack. Here it is the stack. Now I have 1. 1 is having prime counts as 2. Now let us look at the condition of something like I'll tell you the condition, but before that, here I have 1 as the index and 2 is the prime counts. The previous count should be greater than 2. Now let us see in the stack. Here it is till now what are the indices I got is the previous what this stack stores. Now I am having 0, which is having 3. So here st stack dot top. So here it is greater than, sorry, here st.top, the prime counts of st.top is greater than the prime counts of I. So if it is so, then previous greater element of I would be st.top. It would store the indices. So as previous greater of I is changed to st.top, then here if I take the indices 0, 1, 2, 3, and 4. Now previous greater of 1 is changed to 0. Now I would push this. 0 is having something like 0 is the index of previous index. Now for this 0, imagine if I am having this 4. Just imagine I am having this 4. Just for explaining you the next greater element, how does this work? Then I need to remove this 0, and I would store the previous this as the greatest element. Let me tell you this. I would push this one back into the stack. But before that, the next greater of, I'll write the condition here. Next greater of index. Next greater of index would be the current index I, would be changed to I. But when? So index would be something like st.top is something like st.top, and if st.top is having prime count lesser than prime count of I, then I would write a while loop for this until and unless I would get here in this top, I would get the index where previously I am having the count greater than the current index. So this is how the previous greatest element and next greatest element works. Now, how to calculate score for every element as we take power. Now, as I said here, it would be something element of 19, and I am considering the number of subarrays like here, and I would take 19 into something like power. But here, how do I calculate 2 power 10? Now, how to write 2 power 10? I would write 2 power 10 as something like 2 power 5 into 2 power 5. Now, how do I write this 2 power 5? 2 power 5, I would write this 2 power 5 as 2 power 4 into 2. 2 power 4 into 2. Now, how do I write this 2 power 4? 2 power 4 is written as 2 square into 2 square. 2 square into 2 square. Now, how do I write this 2 square? 2 square is written as 2 into 2. 2 power 1 into 2 power 1. Now, 2 power 1 is written as 2 power 1 is written as 2 power 1 into 2 power 0. Now, 2 power 1 into 2 power 0 is 2. So, 2 into 2 is something like 2 into 2 is something like 4. Now, here it would be 4 and into 4. 4 into 4 would be 16. So, 2 power 4 would be 16. But 2 power 5 would be 32. 32. Now, 2 power 5 into 2 power 5. 32 into 32 would be 1064. So whenever I get this 2 power 10, I would simply do n by 2. That means x power n, then I would do n by 2. So x power n by 2 into x power n by 2. X power n by 2. But if it is odd, x power n by 2 into x. This would be the solution for 2 power x, x power n. Now, how do I go through this algorithm? It is quite difficult to understand, but if you keep on watching and do it for twice or thrice, then you can easily understand this question or this problem. Now, first thing what I did is prime factors count. So, take the prime factor count by only considering till root of square root of n for element n. So I would be it would be iterating from 2 to square root of n for every element, and I would be store in a vector. After that, after getting this prime factor count, calculate or take this next greater and previous greater. Now calculate the next greater and and previous greater. So by this next greater and previous greater, I would calculate number of subarrays. Subarrays are calculated and stored in a vector. So after that, I would name this vector as subarrays. Now after this, I would get this subarrays, but before that, while k is something like operations. Now I cannot do all those operations. I would do operations k minus is equal to something like current operations count. Let me say that operation count is equal to minimum of total k minus subarrays of I. Subarrays of I. But before that, can I take the I every time? Subarrays of I? No, nothing like this. So here, before that, I would take the maximum element, max element every time. So push all the elements into a priority queue with index. After that, operation count would be minimum of k and also subarrays of I. So for that, I would get pq dot top. For that, I would get auto index I and also value and at last the score is multiplied by value. I am taking this value and also taking the power. power of value, comma, how many times, operation count number of times. So instead I can take something like power of value, comma, operation count. At last k minus is equal to operation count. So this is how we solve this problem. And in another function you write this x power n function, so that you can compute this power by taking modulo exponentiation. So this is how you solve this problem. If you like this video, do share it to your friends and do subscribe to my channel, and I have given the link of the code or the submission in the description. Go and check it. Thank you.